Saying we're going to be dealing with all the shortcuts. Did you grab the sheet, son? Grab that. We're going to be dealing with all the shortcuts today. This is hopefully going to give you a way to make things move faster on the ones that have a shortcut, but you have to be able to recognize the pattern in order to be able to do these. So we're going to show you what it looked like before. This is the way it looked before. We had a binomial that was squared. When we did that, we squared the first number and made it a squared. We squared the second number and made it b squared. Then we multiplied 2 times the first number times the last number. 2 times the first number times the last number. That's going to give us 2ab in the middle. Now instead of doing that, we're going to go, instead of going forward, we're now going to go backwards, and we are going to get this as our answer. We're trying to get this. So anytime you see the first thing is a perfect square, the last thing is a perfect square, and it fits that pattern, that 2ab in the middle, then you are going to give an answer that is just going to be a set of parentheses. Whatever is the first thing, you take the square root. Guys, what's the square root of a squared? You just divide the exponent by 2. It's just going to be a. And what is the square root of b squared? B. Because this has a plus sign right here, it is going to be a plus in the middle, and the whole thing is going to be squared. And you're finished. That's it. You factored it, and you don't have anything else you have to do. It's a shortcut because you don't have to do a diamond, not an easy diamond, not a hard diamond, nothing. That's it. You're finished. Now, you do check it with the 2ab, which we'll do when we get the numbers. This is just the pattern. I'll show you that in a minute. Okay, here we go on this one. Same exact thing. What's the only difference between this one and the one above it? It's just a minus. A minus b, whole thing squared. The only reason it's different is because that has a minus. So it's going to be a minus in the middle. That's the pattern. This is called a perfect square trinomial because, guys, look at it. There's 3 of them. And the first and the last number are perfect squares. Remember that list? Do you need to write it down? It wouldn't hurt. The numbers are 1, 4, 9, 16, 25. You have to be able to recognize these numbers, guys. We did them before, but we'll mention them again. 49, 64, 81, 100. What's the next one, guys? 1 what? 11 squared. Come on. 121. What's 12 squared? 144. 144. There's also 13 squared. It keeps going, guys. 169, etc., etc. Yes.
I have a question. So, if there was like, you know how like in the second question, it's not, it's like a subtract with a minus and then plus.
It doesn't have it. The second one has always got to be a plus.
Okay.
If the second one's not a plus, it doesn't work at all.
Okay.
Very, very good question. A good thing to bring up. Okay. The only one that can change is the one in front of the second term, and that's going to be a plus or a minus, which decides whether you have a plus or minus. If the third one is like the one in front of the last term is a minus, this doesn't work at all. That's a very good question. Anybody else? Okay. Anything before I go on? Anybody still writing? Okay. Good? Okay, here we go. So guys, this is a pattern. When you see these, and tonight's homework is all about this, so it's really easy. It should go really fast. I had people finishing the assignment for today and tomorrow in class, or at least getting close. A lot of people were getting close. A few people were done. So guys, is 25 a perfect square? Is 9 a perfect square? Then what you do is set up parentheses. The square root of 25x squared would be what? 5x. 5x. And the square root of 9 would be 3. The sign would be a minus, and the whole thing would be squared. Now, listen to me. If you do just this and you don't do the check, you're going to burn yourself on the test. There's going to be one of these that doesn't work on the test, and you have to do it the old-fashioned way with a diamond. So listen to me. You have to do 2 times whatever this first number is, which is 5x, times the second number, which is negative 3. It's just 2 times the things that are in the parentheses. Guys, what's 2 times 5? 10. And 10 times negative 3? Negative 30, and it's got an x on the end. Does it check? Yes, that checks. I need to see that you do this 2 times the first times the last on every one of your problems. I'll show you why on the next problem. Here we go. For this next, y'all know how bad this diamond would be and all the work and the factoring on this? This is a shortcut for a reason. It makes your life easier. But here's a problem. When you do one like this and you go to set it up, you set it up by taking the square root of this. 49 is a perfect square. What is it? 7. And you'd put a y behind it. Would it be a plus or a minus? Plus. And what's the square root of 36? 6. The whole thing's squared. But you have to do the check. And to do the check, you would have to do 2 times 7y times 6. What is 2 times 7y times 6? 84. Does that equal 42? That does not work. Therefore, you could not use this method. This is not the answer to this problem, which means you would have to go back and do a hard diamond, which would mean the whole long. Think how big these numbers would be. 49 and 36 multiplied and then 42 in the middle. That wouldn't be easy numbers. Okay? But you won't know that, and there will be one. I'm telling you now, there will be one like this on your test that doesn't work to fit a perfect square trinomial, even though the numbers are perfect squares. So you have to do this check thing to make sure. Now, 98% of them will, so you need to use the shortcut, but here we go. Guys, when y'all tell me you can't finish this test, one of the reasons is people don't use the shortcuts, and then it bites them in the behind. You need to learn these formulas. Here we go. So what is the square root of 9y squared? 3y. What is the square root of 4? 2. Plus or minus? And it's squared. We need to see if it checks. Here's how we do it. 2 times 3y times 2. Does that equal 12y? So we're good. That checks. Okay. Next, do you see how fast these should be quick, guys? Okay. What's the square root of 4y squared? 2y. What's the square root of 9? 3. Plus or minus? Minus. And the whole thing is squared. 2 times 2y times negative 3. Does that equal negative 12y? So you're good. That's it. You're done. Much, much faster than doing a diamond for these. All right, question? We're not done. We're not done. There's the back. Don't grab your folders yet, guys. We're not done. There's the back. Okay, last one of these. Why did I put this one if we're talking about perfect square trinomials? Why is this problem on there if I'm talking about perfect square trinomials? That's not, 18 is not a perfect square. But what's the first thing you do on every factoring problem in your life? Take out a GCF. What is the GCF for all these? 2. You've got to do that first, guys. When you do, the 2 goes out in front and you keep it because it's a GCF for the whole thing, so you keep it. It's going to be 9x squared plus 6x plus 1. Oh, someone's going to mess this up, guys. Is 1 a perfect square? 1 times 1 is 1. Good. So if 1's there, that is a perfect square. So we can set this up where we have a parentheses. What's the square root of 9x squared? 3x. Square root of 1. 1 plus or minus. And the whole thing squared. We still have to check it. Still have to check it. 2 times 3x times 1. Does that equal 6x? So we're good. That's it. All right. That is all about perfect square trinomials. The other is the difference of perfect squares, so it's a different formula. Does anybody have a question just on perfect square trinomials? Guys, when it starts with 3 and it's a perfect square trinomial, it ends up with 1 set of parentheses. It's really 2 because it's squared, but it's written as 1 set of parentheses with square on the outside. All right. Okay, here we go. For this next one. Alright, difference of, guys, the word should tell you. On our last test, this is what it looked like. What do you do when you have one like this? Foil. When you foil this, a times a is going to be a squared. A times b is going to be minus ab. B times a, guys, when you multiply b times a, how do you write that? ab. And then b times b is minus b squared. What is always going to happen when you have a plus and minus is the same thing? What always happens to the middle two terms? They cancel out and you get this thing that looks like this. A squared minus B squared. This is a difference of perfect squares because the word difference means subtraction. So if we start with what is a difference of perfect squares, it's going to factor into this. You don't need to figure, it's going to just factor into that. So you set up two sets of parentheses. One of them is going to be plus, one of them is going to be minus, because that's how you cancel out the middle two terms. The square root of the first one goes to the front. Guys, what's the square root of A squared? A. What's the square root of B squared? B. There's your answer. You're done. But I need you to you need to write the biggest stars, highlight, do whatever you need to do. This is extremely important. This does not work when you are doing a sum, which means if there is a what in the middle, addition sign, this will not factor this way. This does not work for addition. This only works for subtraction. Guys, that's why it's called the difference of perfect squares. It only works when you're subtracting perfect squares. Questions? Like that's huge, guys. These will not factor if it's a plus in the middle this way. Okay, because it's going to be on your test, I'm telling you. Okay, here we go. Okay, guys, m squared minus 64. Are they both perfect squares?
Yes.
Yes, guys. Do you know when a variable is a perfect square? Because the power on it is even. If you have something like m, or m to the third, or m to the fifth, would that work? No, it's just got to be an even number. So we take and we set up two sets of parentheses, 1 plus, 1 minus. The square root of m squared is going to be what? M. And the square root of 64 is going to be 8. That's it. You just factored it. You're done. Okay. Next one, same thing. Well, first of all, is 16 or are 16 and 169 perfect squares? Mm-hmm. Yes. So two sets of parentheses, 1 plus, 1 minus. Okay. Square root of 16x squared, 4x. Square root of 169y squared, 13y. Okay. Questions, concerns, anything? Anybody see anything that's throwing them off on this? This is a very easy, you said there's no work on these. It's just straight to an answer. There's no checking. It just always, if it's subtraction and they're perfect squares, it always works. Okay, let's keep going. Oh, wait. Sorry, I didn't ask. Is anybody still writing? I apologize. I usually try to ask. Okay, here we go. My fault. Why is example 8 on there if 3 is not a perfect square? Because it has a greatest common factor. So we go to take out the GCF. What's the GCF? 3y. 3y. They both have a y in common. So when you take out a y, it's going to be 3y times. Okay, the 3's cancel out. When you do y squared divided by y, it'd be y minus 27 divided by 3 would be, and what happens to the y's? They cancel out. Guys, can I factor y minus 9? Because what is the power on the y? Is that an even power? So I cannot factor that in the difference of perfect squares. That's where I would end. Is this problem prime?
Yes. No.
Did I do something?
Yes.
Then can I write prime?
No.
No, this is my answer. If I can't do anything at all, then my answer is prime. That's the only time. It's, y'all, it happens so rarely. Okay, let me just give you one quick, is this, yeah, this is our last one. Let me just give you one real quick. Let's say we had, I forget what it was, m squared plus 64. Okay, let's say this is, we'll call it example 10. Put it on there, guys. I just want you to have this, guys, because we didn't have one like this. I want to make sure you see it. Okay, what can I do to this? Can I break this into plus and minus?
No.
Are they both perfect squares?
No.
Then why can't I?
Because you're adding.
Because you're adding. Guys, you can't do it unless you're subtracting. and this is adding. So can I do anything to this problem? No, there's no GCF, there's no factoring, there's no nothing. So this one I would write prime. You only write prime when you can't do anything. Okay. Let's do our last one, guys, because this one actually has a little bit extra in it. The reason is the 4. You'll see what I mean when we go through this. When you split this into 2 sets of parentheses, because those are both perfect squares, what is the square root of y to the 4th? Y to the 2nd. You just divide the power by 2. Y to the 2nd. What is the square root of 81? And one of these is going to be a plus, one of these is going to be a minus. Are you okay so far? Okay, do you see this one has a plus in it? Can it break down any more?
No.
But this one has a minus. Are both the things on either side of that minus perfect squares?
Yes.
Then you could keep going. So we're going to bring down this first one. You cannot change it because it has a plus in it. And then we're going to break this into 2 sets of parentheses. One of them will be plus, one of them will be minus. What's the square root of y squared? Y. And the square root of 9 is 3. Okay? I can't go any further with this one because it's a plus. I can't go any further with this one because it's plus. Can I break down the y minus 3? Because of y. It's a subtraction. The exponent's 1. And, guys, is 3 a perfect square? No, so it doesn't break down anymore. That would be your final answer. Questions, concerns, anything before we move on? Okay. Please take out your folder.